Lilia, it's time to go to the doctor's to get your new leg.
Okay. Thanks, Mom.
You're welcome, daughter.
Hi, I'm Dr. Paufler. You must be Mrs. Lee.
Yeah, nice to meet you.
You must be Lilia.
Hi.
Okay, so your test results are in, and it looks like you'll be a viable candidate for our new prosthetic, so let's go ahead and proceed with the fitting.
So what do we need to know about prosthetics before we continue?
Well, there are a lot of medial and lateral forces that are involved in a prosthetic.
Medieval forces?
No, silly, the medial relates to the middle, so in a prosthetic leg, the medial side of the knee is the side closest to the other knee. The lateral is the opposite of the medial, and it points away from the center of the body. In a prosthetic, the lateral side of the knee is outside of the knee. The anterior is the front side of the body, while the posterior refers to the back side of the body. Then, as you can see in the video, the proximal is the term referring to the place closest to the heart, while the distal is the place furthest from the heart.
So now that we know our basic medical terminology, we can go ahead and start talking about the forces involved in your prosthetic.
Forces? I know all about forces. I learned about it at school with Miss Humes.
There are four main types of forces in a prosthetic: the gravitational force, a normal force, a frictional force, and an applied force. The gravitational force is the acceleration due to gravity times mass, and it acts downward. Next is normal force, and normal force is a contact force. It's perpendicular to the surface, and it cancels out the force of gravity in equilibrium. The next force is the frictional force. This force is a contact force as well, and is directly proportional to the normal force and also depends on the coefficient of friction, or mu. It is opposite direction of movement and is parallel to the surface. Now let's talk about these forces in specific to prosthetics. First is a gravitational force. It is applied by the weight of the person wearing the prosthetic, and creators of prosthetics need to be wary of this force in order to create a prosthetic that is sturdy enough to withstand the weight of the person wearing it. Next is the normal force in prosthetics. This force is applied by the ground, perpendicular to the prosthetic when one is walking. Next is the frictional force in prosthetics. This force is applied on the prosthetic by the floor and prevents the prosthetic from slipping. It is parallel to the surface of the floor and opposite the direction that the person is moving in. The final force is the applied force on prosthetics. This force is applied by nerves and muscles on a prosthetic in order to allow for movement to occur.
That's right, Lilia!
So now that we know about the basic forces involved, we can talk about the inertia and lateral forces in a prosthetic. Basically, there are three main forces specific to prosthetics. These are weight, the inertia effect, and the lateral force. Weight plays a key role in the construction of a prosthetic because the false limb must be able to withstand the weight of the patient, or else it will crack under the pressure. When a person walks, their center of mass shifts laterally towards the foot that is in contact with the ground, meaning the inertia effect comes from the side-to-side motion that occurs during walking, as shown in the diagram. The lateral force is a balancing force that works in tandem with the medial force acting on the prosthetic. This force replaces the need for calf muscles in the false limb. Now let's talk about torque. Torque consists of a perpendicular force times the radius at which the force is applied, causing the object to rotate, which is represented by the Greek letter tau. The forces that are unique to prosthetics create torques. For example, the gravitational force is applied at the center of mass of the body, which is at a radius a from the axis of rotation, in this case the knee, which results in a clockwise torque. The inertia force discussed earlier also provides a force that acts on the axis of rotation, again the knee, at a distance c from the knee, which results in a counterclockwise torque. This counterclockwise torque is much smaller. Lateral force is a bit trickier. Since weight is a large force relative to the small inertia force, there must be some other torque to help inertia cancel the torque due to weight. So to find this counterclockwise torque, if we work backwards, we can find the perpendicular lateral force acting on the knee at a distance b. All three of these torques can be put together in the equation WA equals IC plus LB, and even though there is a small medial force acting here, its radius is so small that its torque is negligible. Now that we've reviewed the physics involved in a prosthetic, are you guys ready to continue with your fitting?
Yeah, we are.
Okay, so we have a new model. It's called the Ratchet 365.
Ooh, the Ratchet 365?
That's right.
Wow!
Sweetie, it looks just like your old leg. I can't even tell the difference.
So in summary, the medial is the side of the body pointing towards the center, and the lateral is the side of the body pointing away from the center. The gravitational force is applied by the weight of the person wearing the prosthetic, as shown. The normal force is applied by the ground perpendicular to the prosthetic when one is walking. The frictional force is applied on the prosthetic by the floor parallel to the surface of the floor and opposite to the direction that one is walking. Then the applied force is applied by nerves and muscles to the prosthetic to cause movement. The force of gravity applied at the center of mass at a radius a from the knee causes a clockwise torque. The inertia force is applied at the center of mass at distance c away from the knee, causing a counterclockwise torque. Since weight is a large force going clockwise and inertia is a small force going counterclockwise, another counterclockwise torque is needed, which is a lateral force applied at radius b from the knee. Therefore, the equation is WA equals IC plus LB, and the medial force is negligible.